Hey everyone, this is question number 88 from chapter 6. All right, so this question asks us to find the reading on a scale if you jump on it from 1 meter high. And we're given a reading if you just stand on it, okay? So we can start by solving for the spring constant of the scale. I'll write out the spring equation first. F equals kx, and then we can rearrange and get k equals F over x. Okay, we're given 760 newtons over 6 millimeters, which is going to be 0.0006 meters. And that will give you a spring constant of 1.27 times 10 to the 6th newtons per meter. Okay. So the next thing we need to do is a conservation of energy between E1, which we're going to call 1 is going to be before you jump and 2 is going to be after you jump. All right, so doing conservation of energy, we're going to assume you're starting from rest, so there's no V, so there's no kinetic energy. So on this left side for 1, we're just going to have mgy1 is equal to, if you are landing it on a scale and you compress it all the way, there's going to be a moment where you're not moving at all, so there's going to be no kinetic energy on the right side either. But we will have mgy2 and the elastic energy of the spring because it's being compressed, ky2 squared. All right, so looking at this equation, you should recognize that we have mg and k, which we just found up here. Okay, force equals mg, mass times acceleration. So we can rearrange this equation and say that mg over k would be equal to x. All right, so we subtract this term over to the other side and divide both of these terms by 1/2 in k. So we're going to get y2 squared plus 2mg over ky2 minus 2mg over ky1. All right, so then we can replace this by xc, x compression, and we get y2 squared plus 2xcy2 minus 2xcy1. All right, so then xc is the compression of 0.0006 meters, and we multiply that by 2, so our final starting equation here is going to be y2 squared plus 1.2 times 10 to the 3rd y2 minus 1.2 times 10 to the 3rd, 10 to the minus 3rd, I'm sorry. This is a really small number, not a big one, equals 0. All right, so now we can use quadratic equation to solve for y2. So quadratic equation, x equals negative b plus or minus, that's a negative, plus or minus the square root b squared minus 4ac all over 2a. Okay, so plug that in. Y2 equals minus 1.2 times 10 to the minus 3 plus or minus the square root 1.2 times 10 to the minus 3 squared minus 4a minus 1.2 times 10 to the minus 3 10 to the minus 3. All right, and then you divide that by 2. And you will get minus 3.52 times 10 to the minus 2 meters and 3.4 times 10 to the minus 2 meters. So obviously the correct one is going to be the negative one because we're working with the scale being set at 0. The scale, like the equilibrium point of the scale, is going to be equal to 0. Okay, so then we have an x, we have a k. We can do F equals kx to get the final reading of the scale. F equals the k that we solved for, 1.27 times 10 to the 6th newtons per meter times 3.52 times 10 to the minus 2 meters. And that's going to give us a reading of 4.5 times 10 to the 4th newtons. Much higher when you jump down on a scale than when you just stand on it.